Okay, so we are, again, my name is Jamal Ashraf. We are working on the chapter 4 of Big Java, and we just covered part 1 for the numbers, and then part 2 is arithmetic operators. So how we're going to do things with numbers. So we have the basic operators just like in math. You have a plus, minus, multiplication, and division. And then expression is combination of the variables with our operators and method. So you put a bunch of them together. Most of you already have some level of math and you have done this in there. But we do things a little different in our programming. So we cannot do everything that you do exactly the way that you were doing it in your math classes. So division, we can use parentheses to make the division. It's going to be doing the a plus b first, and then it's going to divide it by 2. And if I move the parentheses on this side, then it's going to do division. It's going to divide b by 2, and then it's going to add to a. So we can organize things by parentheses. If I don't want to remember order of operation, I just put parentheses around them, and then I don't have to worry about it. If we're mixing up the floating point and integer, it's going to automatically raise it to floating point. So Java does move things just like C++ to the higher one. So if I have two glass of, if I have two glasses and I have some things in there, one is much bigger, one is a smaller one, it's going to make more sense to put things in the bigger one than put it in the smaller one. So it's automatically going to change it. So if I have 7 as an integer, it's going to automatically become 7.0, and then it's going to add with 4.0. We have a plus plus and minus minus. That's going to be incrementing 1 or decrementing 1, instead of saying counter equal counter plus 1, which we can do it. There's nothing wrong with that. We can just say counter plus plus, or instead of saying counter minus, counter equal counter minus 1, we can say counter minus minus. So we could, so counter equal counter plus 1. I want to be sure that you guys are putting some spaces between your operator. Don't put everything together. So this is going to be much harder to read. But we want to be sure that we put the spaces around our operator to be easier to read. So this one with plus equal 1 and counter plus plus. These are all the same thing. You can choose whatever you want to do. But because I don't want to type that much, I usually go find the one that's less typing. And same thing goes with the negative one. It's going to be counter minus 1, minus equal, minus minus. All right, so as I said before, when you are mixing up the integer with decimal, it's going to promote it to decimal. That means when I have a mixture of 7 divided, so in this case, it's going to change 7 to 7.0 or 4 to 4.0. So all of them is going to be turned to decimal, and it's going to divide it. One of the things that we have to keep in mind, especially if you're new to programming, is in Java and C++, integer divided by integer is going to give you integer. It does not give you decimal point. So 7 divided by 4 is going to give you 1. It does not give you 1 point whatever. 5 divided by 2 is going to give you 2. So integer divided by integer will give you integer. You got to keep that in mind. Then we have a percent for modulus. We can call it modulo or mod. That's going to give you the remainder. So if I divide 7 by 4, what is my remainder? So I'm going to get 1 remainder of 3. All right, where are we going to be using these things? So let's say that we have dollar and cents. We have a value, and then we want to separate dollars and cents. So what we can do is if we divide it by 100, which is a value of $1, then we can get how many dollar do we have. So we get this, we divide it by 100, it's going to give me 17. So it's going to be $17. And if I do percent 100, it's going to give me 29, which is the remainder of pennies divided by 100. So these are some applications that we're going to need that integer divided by integer to be sure that we understand integer divided by integer is going to give us integer, and that is a useful thing, and we have to practice on it. For some of us, we need to practice more. Okay, let's go over some practice. Let's think about this. Again, having a paper and pen or some kind of a computer program to write on it or document or however you want to do it. We can go through this and you can always come back to this and try it again. So my N right now is 1729. My N is 1729. I'm doing percent 10. That means I'm going to divide it by 10 and I'm going to get the remainder. What do you think is going to be? 1729 divided by 10 and getting the remainder. So generally, we're just going to, if we divide it by 10, the last digit is going to go away and the remainder is going to be just the last digit. That means what? If I divide it by 10, it's going to be 172. How about 100? So we're going, instead of 1 digit, we go 2 digit. So percent 100 is going to give me 29. What about if we divide it by 10.0? Remember, when we are mixing up integer with decimal, it's going to change my integer to decimal. So that means I will get a decimal point. And we cannot use modulus because there is no remainder for a decimal point. So if I get 1729 divided by 10.0, I'm going to get 172.9, and that doesn't give me any remainder. If I change my number to negative number, of course, it's going to give me negative number. And this is very useful. Percent 2 is going to give me 0 if the number is even, and it's going to give me 1 or negative 1, depending if the number is negative, if it's odd. So that's one way to check to see if our number is even or odd. We can do percent 2 and figure out what it's going to be. So, as we talked about it earlier, the math class module has a bunch of variables and methods that are defined as public static. So for that, we can call them without creating an object or input. So I can call math.square root. It's going to bring the square root method from the math. So I can put a number in there and it's going to return the square root for me. we have the power in there too for the math. So it's going to be the first number to the power of the second number. We can use POW for x to the power of 2, but it could be just x times x as well. Okay, so let's think about this for a second. We have b times 1 plus r over 100 to the power of n. How can we do this? So we know we have the POW for this power. We know we have division for r. What about the parentheses? What about this multiplication? So we're going to come back to this again. So this in Java is going to be b times, and then we're going to have the power for the n that goes right here. And then we have our 1 plus r divided by 100. This works because of the order of operation, meaning that division comes before plus. Otherwise, I would put some parentheses around it to make it more clear or not to worry about order of operation. So if you remember order of operation, some of you remember, please excuse my dear Aunt Sally, some of you guys are pandas or some things that matter. So we're using the parentheses, exponent, multiplication and division. I put them in the same level because they are, multiplication does not come before division. They are in the same level. So if you have something in the same level, it's going to start from the left to the right. And same thing goes with the addition and subtraction, meaning that multiplication and division happens before addition and subtraction. So if we go through this, if you're looking at this, so inside of this parentheses, we want to do the parentheses first. Then inside the parentheses, I have a plus and I have a division. So the division comes first. We're going to do the division first. Then we're going to add 1 to it. Then we're going to do the power, because it's part of these parentheses right here. And then we're going to do the multiplication. These are some of the methods that's available in math module. We don't have to memorize them. We just got to know that's available. Some of them we're going to be using it in this class. Some of them you may or may never ever use them. So a square root, power, sine, cosine, we are not going to use it. Round is a very good one to use. So the round method is going to take your number. It's going to look at the decimal point. If it's a 5 and above, it's going to change it to the higher number. If it's less than that, it's going to change it to lower number. So if I have 13.6, round is going to make it to 14. If I had 13.2, round is going to change it to 13. The ceiling is going to take it all the way to the top. So it's always going to raise it to the higher one as a double. And then we have floor, which is going to floor it as a double. Radius to radius and to degrees, absolute value is going to take the sign out of it. We have the max that we have it in our assignment to use it. We have a mean, so it's going to return the maximum or minimum of those. We have exponent in there if we need to do e to the power of something. And we have the logs that we are not going to use it in this class. Okay, so now that we are looking at these numbers, it's okay, we have floating number or decimal number, and we have int. Sometimes we want to go from one to the other one. So in C++, this is allowed. In Java, is not allowed. So if you have a double and you want to make it to an int or assign it to an int, Java doesn't let you do it. So we have to do some kind of a typecast. So if my balance is double and I try to assign it into an integer, the compiler doesn't let me do it. So I'm going to be using a typecast. That's going to be the parentheses with the data type. And now my balance becomes integer. Now I can add it. And this way, the compiler is sure that I know what I'm doing. I would purposely want to change this to the int. So when I force something to be int, it's going to get rid of my decimal points. It doesn't matter. It doesn't round it. It doesn't do anything else. It's just going to get rid of the decimal point. So 13.6 becomes 13, and 13.2 becomes also 13. So the round is going to be the one that's going to be rounding my number. So 13.75 becomes 14. And remember, if I put the int in front of it, it's just going to get rid of the decimal point. Okay, let's go over some arithmetic expression with the idea of having order of operation. So in this case, I have an addition and I have a division. So I know the division comes before addition, but for me to be able to do the division, I have to figure out my nominator to be able to do it. So how do we write this in Java? Any suggestions? So we're just going to do x plus y divided by 2. Because division comes first, if I didn't put the parentheses, it would divide y by 2, then it would add it to x. That's why we need parentheses here. What about xy2? Remember, xy, we don't have that in Java. We have to define our multiplication. So we have to say x times y divided by 2. I want to emphasize again to put spaces around your operators to be easier to read. Because multiplication and division are in the same level, it's going to do the left one first. So I don't need any parentheses, but if I don't want to worry about it, or if I don't want people to think about it in the future, I can potentially put a parentheses around. How about this? 1 plus r over 100 to the power of n. We did something similar to that earlier. So I know how to do the power, math.pow. Then I have my division and I have the addition. So math.pow, 1 plus r divided by 100, comma, and this parenthesis for the whole parenthesis. How about a square root? So again, I know how to do a square root for a math square root. And now I have a square of a and a square of b. And remember, we have two options to use the POW or just say a times a, b times b. Okay, how about this? I have I plus j plus k divided by 3. We're just going to put the parentheses around it and divide it by 3.0 because we want to have a decimal result or double result. Okay, if I want to use pi, of course, most of us put 3.14. That is not the exact number for the pi. The best way to do it is just use the pi that's available in math class. Okay, so that concludes this part. I want you to think about these self-checks. and then we're going to do it as an activity in our class. So a bank account earns interest once per year. In Java, how do you compute the interest earned in the first year? Assume variables percent and balance of type double have already been declared. So push pause, write it down, think about it, and then we're going to answer this in the class. How do you compute the side length of a square whose area is stored in the variable area? So we have a variable area, we want to find the side. Again, push the pause, think about it, write it down. Okay, this is a volume. How do you write this in Java expression? One thing that you have to remember, 4 divided by 3. Integer divided by integer is going to give you integer. It does not give you a decimal point. So if I not be careful about 4 divided by 3, it's going to give me 1. So basically this 4 over 3 is going to be useless. You got to keep your eye on that one. We did this earlier, so should know how to do it. So what is n divided by 10% 10? You might want to use an actual number to figure it out. Okay, that concludes this section, and we